Okay, today we're going to talk about the volume of pyramids, cones, and spheres. Let's see if I can make this a little bit bigger. It'll look a little bit better. So turn to page 6 where it says day 3. It's about halfway down the page. And let's go over this a little bit. I can't see it very well, and I don't think you'll be able to see this in your packet. For some reason, we have a line that's blotting this out here. So this is supposed to say pyramid, A-M-I-D. And this, of course, is talking about the volume of the pyramid. And we have to make sure that you have the formula correct. So the volume of the pyramid equals 1/3 times, and this should say area of the base times the height of the pyramid. Okay, so this should read capital V equals 1/3 capital B for the area of the base times H, the height of the pyramid. So you can see when we're looking at the volume of the pyramid and the cone, those two shapes are almost the same as the volume of a prism and a cylinder, except we're inserting 1/3 in front because a pyramid actually holds 1/3 the amount of the same rectangular prism, and a cone actually holds 1/3 the amount of the cylinder with the same height and the same base. And then lastly, these two kind of go together because they're the same formula. We just inserted pi r squared for B, because we know the B is a cylinder, there is a circle. And then lastly, we're going to talk about the sphere, which is just a ball, and that has its very own formula, and it's 4/3 times the pi times the radius of the sphere cubed. So we say 4/3 pi radius raised to the third power, not squared, but raised to the third power. And there's a button you'll probably use. It looks like that in your calculator, and we call that the caret button. And then, so for a problem here, I would write in my calculator 4 divided by 3 times pi, and then I'd put in my radius times, let's say 5. My radius is 5. Hit the caret button, third power, enter. And you'll notice that the 3 is up here as an exponent to the 5. Okay, we'll get into that a little bit more when we get to a sphere problem. Okay, so let's look at this first pyramid. Looks like my pyramid really up on the front table here, except these aren't kilometers, they'd probably be inches. So I asked myself, what shape is the base? Now on a pyramid, it's pretty easy to see the base because it's going to be opposite this vertex. So if I go straight down, I see the base, and here it is. Look at the dimensions, and you see 3 and 3. So it must be a square. Let's just name it up here. A square pyramid, named by its base. So the base is this square, the 3x3. So 3 times 3 is how I find the area of a square. So that equals 9. The height is the perpendicular height from my vertex to the middle of my base. And so it's showing me here that that height, that perpendicular height, is 2. So now remember, to find your volume, we have to insert this 1/3 times our area of our base times the height of the pyramid. So we could do 9 times 2 divided by 3, or 9 divided by 3 times 2, or you could put in your calculator 1 divided by 3, close the parentheses, times 9 times 2, and whatever way you do it, we should be getting 6, and this is volume, so we're going to say kilometers cubed. Let's make sure we can all get that same answer, 6. Okay, now let's go over here to number 2, the second example. I can see it's a pyramid. I can see the vertex is directly over the center of this base. And what is the shape of the base? Okay, 5 inches and 4 inches. That makes it a rectangle. So it's a rectangular pyramid. So to find the area of our base, we need the area of the rectangle. And since it's a rectangle, length times width will give us 20. Our height is our perpendicular height, and they're giving it to us right here. It says that it's 5 inches. And so our volume, because it's a pyramid, is 1/3 times 20, the area of our base, times our height, which is 5. So we get 1/3. Oh, is that a 5 or a 6? Maybe it's a 6. Okay, on my book, I wrote this as a 6 because in the book, it looked more like a 6. So change that in your diagram there so it looks more like a 6. And I'll go back and make our height 6. Okay, so 1/3 of 20 times 6. 20 times 6 is 120, and 1/3 of 120 is 40, and that's inches cubed. Okay, square pyramid, rectangular pyramid. The most important thing is for pyramids, we're using the formula 1/3, the area of the base times the height. Don't forget to put in that 1/3. Okay, next we have a triangular pyramid. So I need the area of my base, which is a triangle. Okay, so I'm going to put my capital B. And how do I get the area of a triangle? Base times height divided by 2. So I'm going to take my 8 and my 6 and divide it by 2. 8 times 6 is 48, divided by 2 is 24. The height, meaning the perpendicular height of my pyramid, is right here, 7. So when I go to do the volume, because it's a pyramid, 1/3 capital B times my height of the pyramid, perpendicular height. So 1/3 of 24 is 8 times 7 is 56 meters cubed. Again, this one is a triangular pyramid, so our base is the area of the triangular. And this is the cone. Now the cone is just the same formula. We just need the area of the base over here. And I think that we're looking at this as a 5. So it looks like halfway across is a radius. So to find capital B, I'm going to take my radius. Remember, it's pi r squared for a circle. So when I square the radius, 5 times 5, I get 25. So the area of my base is 25 pi. How tall is my cone? Again, it's a perpendicular line from the center of the base to the apex, just like on the pyramid. The height is 12. So now to get the volume, again, this is 1/3 of the cylinder, so I want to make sure I put in 1/3 capital B, which I said was 25 pi, times my height, which is 12. So when I do 1/3, and I can do, this is all multiplication here, 3 different numbers. 1/3 of 12 is 4, times 25 pi is 100 pi. And if you want to put that in your calculator, it'll approximately be 314.2. And that would be miles cubed. Okay, this is a cone. Let's call it what it is up here, a cone. Okay, and our last example in notes is a sphere. So anything that looks like a ball is a sphere. So let's remember again what that formula for a sphere is, because it's different than all the others. 4/3 times pi times radius cubed. So this 20 right here goes all the way across the sphere, so that is the diameter. So I want to make sure I get the radius, which is half of the diameter. It's 10. So for my volume, I'm going to go ahead and plug this in, 4/3 pi, and my radius to the third power. Now when I raise a number 10, 100 powers of 10 to a power, that's just counting my zeros. 100 is 10 to the second power, 10 is 10 to the first power, so 10 to the third power is a 1 with 3 zeros. So I can already shorten this up. 4/3 pi times 1,000. 10 times 10 times 10 is 1,000. So I'll show you how to put this in your calculator. We're going to start with opening a parenthesis. 4 divided by 3, close the parenthesis, times pi, hit your pi buttons, second pi probably, times 1,000, and then hit the enter button. So you're probably going to get something like 1333, I think it is, 0.33333 as far as it goes. Pi, if it's in terms of pi, or if you go ahead and multiply that out, let me just check and see what I get so we can round that. And when I go ahead and put it in my calculator times pi, I'll get 4,188.79, rounding to the hundredths, because next came a 0, yards cubed. Pretty big ball. Okay, let's look at our homework problems. And those homework problems will be on page 17, starting on 17. We'll do a couple practice problems together. Let's see if you can find the base, the area of the base, the height, perpendicular height, and then the volume, which I'm going to remind you. Start with 1/3 times the area of the base times the height. And let's try the same thing with number 2. See if you can find the area of the base, it's a square, the height, perpendicular, and then the volume, 1/3 the area of the base times the height. Take a minute now and see if you can do that. Okay, so when I look at this circle here, it looks to me like the diameter is 10 because they're showing a line that goes all the way across. So that means our radius is 5. So the area of my base would be 25, or 5 squared, times pi. My height is perpendicular, that's the 12. So for my volume, I want to do 1/3 times 25 pi times 12. So I'm going to end up with 100 times pi, which if you put that in your calculator, you'll get 314.16 inches cubed, rounding to the hundredths, or 0.2 if you're rounding to the tenths. Over here on our square pyramid, we're going to get an area, because it's a square, side times side is 36. Our height is the perpendicular from the apex or the vertex to the middle of the base, so that's 5. So now we're going to put in 1/3 times the area of our base, so 1/3 times 36. 36 divided by 3 is 12, times 5 equals 60 miles cubed. Okay, and one more problem we're going to do together, which is on page 18. Since this is a triangular prism, remember we need to be able to find the area of the base, and it's a triangle, so 8 times 6 would be base times height, and that's 48. Divided by 2, we get 24. The height of our triangular pyramid is 8, so our volume is 1/3 times our base times our height. 1/3 of 24 is 8, times another 8 would give us 64 meters cubed. Okay, I want you to finish pages 17 and 18, and then we're going to do some board practice. So ask questions if you have any.